differentiation. Now we have covered the exercise 1.1 and today we are going to start our new topic, geometrical meaning of derivatives. What is meant by derivative? Finding the derivative means what we are finding. So let us consider the point P on the curve f of x. At x is equal to a, the coordinates of the point P are a and f of a. Suppose this is our curve y is equal to f of x. I have taken the point x is equal to a, for which I will get the value of the function as f of a. So the point on this curve is P a f of a. Now we will take the another point Q on the curve little right to the P. So this is right to the P at x is equal to a with the value increased by small real numbers. Take a small value of real number. Suppose so just like a delta x. Here a and here it is a plus h, where this h is very small number. So we get the corresponding value of the function is f of a plus h. So the coordinates of the point P, Q are a plus h, f of a plus h. And now we calculate the slope of the secant line PQ. We will find the slope of this secant PQ. Now how to find the slope of the secant passing through the 2 points? It is given by y2 minus y1 upon x2 minus x1. By this way we get the slope of the line. So f of a plus h minus f of a upon a plus h minus a. But a plus h minus a is nothing but h. So what you get? F of a plus h minus f of a upon h. Now suppose we make h smaller and smaller and smaller. If we make this h as small as it possible, then this a plus h will come nearer to a. So as h tends to 0, this a plus h will approach to the point a. Suppose we take the h smaller and smaller, then a plus h will approach a as h gets closer to 0. So q will approach to p, that is as h tends to 0, the secant converges to the point tangent at p. So if I extend this line, this secant, as extend this line, just like okay, by this way, and as this h is gets very small, suppose this h is here, a plus h is here, then I will get this line as this. After some time, it like this. So at final stage, I will get the line which passes through only the point P, and that is if the we know that if a line is touches the curve, then it is a tangent to that curve. Okay, so finally I will get the line like this only. Okay, and this line is we called it as to be tangent of the curve. So the limit of this secant as h tends to 0, limit of this secant as slope of this secant PQ as h tends to 0 is nothing but limit of this function f of a plus h minus f of a upon h. But it is the definition of the derivative using the first principle, and it is given by f dash at a. So from this discussion we conclude that the derivative of a function y is equal to f of x at any point p of x1 y1 is the slope of the tangent at that point on the curve. Always keep in your mind, this is very important. Finding the derivative of the curve at any point is the slope of the tangent to the curve at that point. Okay, now For example, suppose if y is equal to x square plus 3x plus 2, then slope of this tangent at 2, 3 is given by. This is the curve, so we will find its derivative. Slope is nothing but derivative of this curve at the point, at the given point. So derivative of the curve is d by dx of x square plus 3x plus 2 at the point 2, 3. So its derivative is 2x plus 3 at point 2, 3. So I will put x is equal to 2, and there is no y, so no need to put y. So 2 into 2 is 4, 4 plus 3 is 7. So slope of the curve, slope of the tangent to the curve at this point is 7. Now what is meant by derivatives of the inverse function? Now we know that if y is equal to f of x is 1, 1 and onto function. Why it is 1, 1 and onto? Now it is to define the inverse of the given function. It is necessary to the function having 1, 1 and onto. If the function is 1, 1 and onto, then and only we can define its inverse function. Y is equal to f of x, then x is equal to f inverse of y. So this f inverse of y is differentiable, then we can find its derivative. So let us discuss the derivatives of some inverse function and the derivatives of the inverse trigonometric functions. For example, suppose y is equal, f of x is equal to 2x minus 2, then its inverse is f inverse of x. Now how to find the inverse of the given function? Okay, this from this expression we have to find the inverse of the given function. So I will call it as y is equal to 2x minus 2. So how to find the inverse? You have to find just value of x in terms of y. I will take this minus 2 to this side. I will get y plus 2 is equal to 2x. So in next step, I will write x is equal to y plus 2 divided by 2. So this is nothing but our function. So I am replacing just x, y by x. Okay. So this is, by this way we can find the inverse of the given function. It is very important, and we have to find the inverse function of so many functions. So keep studying. So g of x is equal to this f inverse of x. So if you find the derivative of these functions, we see that d by dx of f of x. So d by dx of this the given function. So 2x minus 2, its derivative is 2, because minus 2 is having the derivative 0. And d by dx of this f inverse of x is 1 upon 2 is constant, so we can take outside. The derivative of x is 1 plus derivative of 2 is 0. So we get 1 upon 2. So d by dx of f of x is 2, and d by dx of g of x is 1 upon 2. So they are inverses of each other. So it is clear that the derivatives of reciprocals of one another. So on this we will learn another example. Y is equal to f of x is equal to x square. Let g is equal to f inverse. Therefore, g of y is equal to x root of y again. Okay, you can calculate it. Y is equal to f of x square. So taking the square root on both the sides, you get x is equal to root y. This is nothing but the inverse of the given function. So what is the derivative of g of y? Is root x derivative 1 upon 2 root x. So root y's derivative 1 upon 2 root y. And f dash of x, its derivative, f of x, its derivative is 2x. So d by dx of g of f of x is given by g dash of f of x, f dash of x upon 2 root f of x, g of f of x. So 2x upon 2 root x square. So 2 gets cancelled. Root of x square means x. So x also gets cancelled, and you get 1. So g of f of x is x. So d by dx of g of f of x is d by dx of x is 1. That means at point x, x square on the curve f dash of x is equal to 2x, and g dash of y is equal to 1 upon f dash of x. Let us learn the theorem which may asked in the board exam for 4 marks. So you have to study by heart. and recite it well. What is the theorem? Suppose y is equal to f of x is a differentiable function on x on an interval I, and y is a 1 1 on 2, and dy by dx is not equal to 0. Y is 1 1 on 2 and dy by dx is not equal to 0 on I. Also, if f inverse of y is differentiable function on f of I, so what they are saying that the inverse function is differentiable, then we can differentiate the inverse function, and its derivative is given by 1 upon f dash of x. So finding the derivative of the inverse function means we have to find the derivative of the original function, and you have to take the reciprocal of its derivative. So or dx by dy is equal to 1 upon dy by dx, where dy by dx is not equal to 0. It is already given. Now what is the given? Given that y is equal to f of x and x is equal to f inverse of y are differentiable functions. It is given in the note. So let there be a small increment value, say of x, say delta x. Then the correspondingly there will be an increment of in the value of y, say delta y. So as delta x and delta y are increments, so they are not equal to 0. None of them is 0. So we will consider the incrementary ratio, product of the two incremental ratio, delta x by delta y into delta y by delta x. So this, they are non-zero, so they will cancel each other and I will get 1. So delta x by delta y is equal to 1 upon delta y by delta x, where delta y by delta x is not equal to 0. Now taking limit as delta x tends to 0 on both the sides, what we get? Limit of delta x by delta y as delta x tends to 0 is equal to limit of 1 upon delta y by delta x as delta x tends to 0. But y is a function of x, and as delta x tends to 0, delta y automatically gets to change to 0. So I can replace this limit. Limit of delta y tends to 0 of delta x by delta y is equal to 1 upon limit delta y by delta x as delta x tends to 0. This is our equation number 1. Now it is given that y is equal to f of x is a differentiable function of x. Okay. So the limit of delta x by delta y as delta y by delta x is equal to, so we have limit of delta y by delta x as delta x tends to 0 is equal to dy by dx, and dy by dx is not equal to 0. Since the y is differentiable function, we can write this. So from equation 1 and 2, from equation this 1 and this 2 combined together, you get limit of delta x by delta y as delta y tends to 0 is equal to 1 upon dy by dx. This is our equation number 3. Now here you can see that 1 upon this dy by dx is not equal to 0. So 1 upon dy by dx exists and is finite. And as this limit is finite, so right hand side exists. And as right hand side exists, the left hand side must also exist and finite. Hence, using the Leibniz notation, I can write this limit of delta x by delta y as delta y tends to 0 is dx by dy, and I will put this value in the third equation. So I get dx by dy is equal to 1 upon dy by dx, where dy by dx is not equal to 0. This is very important to find the derivatives of the inverse function. Sometimes it is very difficult to find the derivative of or express y in terms of x. In that case, we have to find the derivative of x in terms of with respect to y and use this formula to find the derivative of the given functions. Okay. What is the example? Find the derivative of the function y is equal to f of x using the derivative of the inverse function x is equal to f inverse y in the following. What they asked, they have not asked to find the derivative of the y with respect to x. We have to find the derivative of y with respect to x, but using the derivatives of the inverse function. Now how to find it? Now what is given? Y is equal to cube root of x plus 4. So here first we have to express x in terms of y. Here they have expressed y in terms of x. That means y is a function of x. Okay. Now we have to find the inverse function of the given function. Y is equal to f of x. That means we have to find x in terms of y. That is called the inverse function. Now how to find the inverse function? What is given? Y is equal to cube root of x plus 4. So taking the cubes on both the sides. So y cube is equal to x plus 4. And from this relation, we can find the value of x, y cube minus 4. So this is our inverse function. X is equal to f inverse of y is equal to y cube plus y cube minus 4. And we will find the derivative of this. Now dy by dx is equal to 1 upon dx by dy is equal to 1 upon d by dy of y cube minus 4. Now what is the derivative of y cube? Y cube, its derivative is 3y square, and minus 4, its derivative is 0. So 1 upon 3y square. So this is the derivative of x with respect to y. But what is y? Y is cube root of x plus 4. So I will put the value cube root of x plus 4 and its square, where x is not equal to minus 4. Similarly, find the derivative of the function y is equal to f of x using the derivative of the inverse function x is equal to f inverse of. Same type of problem is given here. Y is equal to square root of 1 plus root x. Again, what is given? We first find the inverse function of the given function. Y is equal to f of x. So we have to write x in terms of y. Now how to write x in terms of y? Taking the squares on both the sides, we get this equation. Now again, I will take this 1 to this side. Y square minus 1 is equal to root x. Then again I will take the square. So I get x is equal to f inverse of y is equal to y square minus 1 bracket square. Now here dy by dx is 1 upon dx by dy. Okay. So the 1 upon d by dy of the given function y square minus 1 bracket square. So its derivative is 2 times y square minus 1. Here f of x square is 2 times f of x into f dash of x. Use that formula and find the derivative. You will get the derivative by this way. Then we have to substitute the value of y. So we get derivative of y with respect to x. Third example, find the derivative of y is equal to f of x using the derivative of the inverse function. X is equal to f inverse of using the derivative of the function. So we have first, you must find the inverse function of the given function. Y is equal to ln of x. So that is y is equal to log of x to the base e. So what is x? X is equal to f inverse of y is equal to e raised to y. Now already we learned the definition of log in 11th standard. So a raised to m is equal to x. If a raised to m is equal to, I will write here, a raised to m is equal to x if and only if log of x to the base a is equal to m. This is the definition of the logarithm. So here y is equal to log of x to the base e. Y is equal to log of x to the base e. So we have to write it in the exponential form. So here a is e, x is x, and m is y. So I get e raised to y is equal to x. Okay. So by this way you can find the inverse function, and after finding the inverse function we will use the definition of derivative of the given function. Dy by dx is equal to 1 upon dx by dy is equal to 1 upon d by dy of e raised to y. 1 upon e raised to y. So e raised to ln of x is an e raised to ln of x. Again we use the property a raised to log of x to the base a is x. Now finding the derivative of the inverse function y is equal to, and calculate its value at x is equal to minus 2. What is given? Y is equal to 2x cube minus 6x. Now here it is not possible to find the its inverse function because here one is x cube and other is x. Okay, so we will differentiate this with respect to x. What is the derivative? 6x square minus 6. We can take 6 common, we get x square minus 1. So we have the derivatives of the inverse function as dx by dy is equal to, so dx by dy is equal to 1 upon dy by dx. So dx by dy is equal to 1 upon 6 times x square minus 1. Now we want derivative at x is equal to minus 2. So put x is equal to minus 2 means y is equal to 2 times minus 2 cube minus 6 times minus 2. So what is the y? Y is minus 4. So put this equation dx by dy at y is equal to minus 4 is same as 1 upon dy by dx at x is equal to minus 2. So the derivative is 1 upon 18. Let f and g be the inverse function of each other. The following table list gives the values of f, g and f dash. Already such type of example we have started in the last lecture. So in g dash of x is equal to 1 upon f dash of g of x. So put the values and you will get the corresponding solution. So just go through this video and write it in your notebook.